Hello dear viewers, today I am going to show you how real-time temperature can be shown in PC-based SCADA HMI or SCADA interface using Arduino and the temperature sensor LM35. I have created my user interface using CX Supervisor SCADA software and made this SCADA HMI interfaced with Arduino via Arduino OPC Server. Before to start the project, let me show you the hardware and software components used in this project. In this project, I have used Arduino UNO Micro Controller, and for measuring the temperature, I have selected the temperature sensor LM35. This sensor has temperature measuring range from -55 to 150 degrees centigrade. For wiring, connect sensor positive terminal to Arduino 5V pin, sensor ground terminal to Arduino ground pin, and the sensor output terminal to Arduino analog input pin A0. As the main purpose in this project is to show the sensor temperature in PC-based SCADA, Arduino has been connected to the PC via USB cable. This is my practical hardware setup for this project. The connections for these hardware components have been made just as according to my previous description. Now for interfacing the Arduino with PC-based SCADA user interface, it is mandatory to run the Arduino OPC server on the PC Windows system with proper configuration and settings so that this Arduino OPC server will communicate with the Arduino and will be able to read-type the sensor data from the Arduino in OPC format and provide this OPC data to any OPC compliant SCADA user interface. Last of all, select a OPC compliant SCADA software and create a user-friendly SCADA HMI using this SCADA software. Today's almost all the SCADA and DCS softwares have the ability to receive the OPC data from any OPC server. I have CX Supervisor SCADA software downloaded and installed on my PC. You can get the trial version for CX Supervisor SCADA software from the Omron official website. Finally, when both the Arduino OPC server and the CX Supervisor SCADA user interface will be running on the PC, Arduino OPC server will retype the sensor data from the Arduino and will provide this data to CX Supervisor SCADA user interface to visualize the temperature. Let's start the project by first creating an appropriate OPC case for the Arduino, which will enable the Arduino communicates serially with the Arduino OPC server, and through this OPC server, Arduino publishes the sensor temperature data to the connected SCADA client. The required OPC case is now open in my Arduino IDE. Let's have an idea about how this OPC case will work for the Arduino. The first thing you have to do is to include the OPC libraries into the Arduino IDE for creating OPC case. It can be done in a couple of ways. The simple way it can be done is just go to the Case button in the menu bar. From the drop down list, select Include Libraries and click on the Manage Libraries button. Note that the libraries index are downloading from internet, so you have to make an online connection for your PC. When finished downloading the OPC libraries index to the library manager, put the cursor here and write OPC. Note that the OPC libraries have already been installed into my Arduino IDE. If you do not have this, there will be appear a button for, and you can easily install the OPC libraries by clicking on this button. Now go back to our OPC case. Once finished, you have finished installing your OPC libraries into Arduino IDE. You can start writing the OPC case by first including the library's header file opc.s. Let's go ahead and take a look at this object OPC serial, OPC serial, which we have to declare in OPC case for defining which type of communication we are using to connect the Arduino to the Arduino OPC server, as USB cable has been used to establish the physical connection between the Arduino and the PC, and the data exchange between the Arduino OPC server and the Arduino will be done over serial. I declared this object for serial communication. Move to the callback function. This function will be executed when any connected SCADA client want to read or write the real or virtual input-output pin of your Arduino or any other calculated value in the OPC case. Here we have to return the temperature value to the SCADA client. In this line of code, the variable called vout gets the value from the analog read function ranging from 0 to 1023. To get the actual value for temperature, a conversion has been made in the next line of code, and the variable called temp gets this actual value for temperature from this conversion. Every time the connected SCADA client will call for temperature value, this callback function will return the value of this variable called temp. Now for placing the temperature value to the connected SCADA client, we have to declare a variable generally called OPC tag or OPC item. I declare A0 as the OPC item, and this line of code shows the way for declaring OPC item or OPC tag. You can give any name for your OPC item. This OPC item A0 will be discoverable by the any OPC compliant SCADA client during operation, and the OPC client will get the temperature value from the Arduino by this OPC tag. Last, finish your OPC case by including the void loop function that has the line of code OPC serial process OPC commands. Before to upload this OPC case to Arduino, click on the verify button to check any errors for this OPC case. No errors found for this case. Now click on the upload button to send the OPC case to Arduino. Arduino has been loaded with this OPC case. We'll now perform a test for available OPC item by serial monitor. Go for serial monitor, place the cursor here and press enter. Note that Arduino has responded with the OPC item A0 that we have declared in the OPC case. Now for testing the value for sensor temperature, write the name of the OPC item and press enter. Note that Arduino has returned the value for sensor temperature. The sensor is sensor LM35 is sensing right now. After uploading the OPC case to Arduino, one most important thing I want to talk about the Arduino OPC server and the process for installing for configuring it. Arduino OPC server is a software application that runs on the PC Windows system and connects the Arduino to the SCADA client. It is a free software. You can get it from the website st4makers.com. For downloading and installation of this software, you can follow the instruction provided in this software pages. After downloading and installation, I have to come to get this file Arduino OPC Server.x. If I double click on it, it will be running on the PC, which can be visible as an icon in the system tray. Though this OPC server is running on this PC, it will not communicate with the Arduino if we do not make the proper settings for this OPC server. So for settings, go to the server icon, double click on it to get the full window. Note that there are 3 tabs on this Windows: Information, Configuration, Info tab. Go to Configuration tab. Under these tabs there are options to set configuration for serial or Ethernet communication. As we want to make the Arduino communicate serially with the Arduino OPC server, click on the Arduino serial. We get the Arduino serial 0. On the right side there is an option to make settings for serial port. Here we have to select which USB port or COM port we are using to connect the USB cable coming from the Arduino. The USB cable from Arduino has been plugged in COM port 3 of this PC, so select COM 3 for serial port. Leave other settings just as same. Now click on this to save this configuration. This completes the configuration for Arduino OPC server. The Arduino OPC server in the next time will start with this saved configuration. To visualize the temperature in SCADA from Arduino, we have to create a SCADA interface using a SCADA software which is capable of receiving the OPC data from Arduino OPC server. A graphical user interface has already been created using CX Supervisor SCADA software, which is now open in this software environment. Now for monitoring the temperature using this graphical user interface, we have to add the Arduino OPC server to this SCADA project and connect the OPC item provided by this OPC server to the graphical objects of this user interface. This can be done by creating a variable or point which is internally used in the CX Supervisor project. This point accesses the I/O data from PLC or any other source like Arduino OPC server. Go for point editor and note that a point has been created to get the temperature data through the OPC item. When this point will be connected to the graphical objects or elements of this user interface, these graphical objects will show the value of the point, which represents the value of the sensor temperature. Now take a look at what settings we have made during creation of this point. Double click on this point to get the dialog box for modify point. The point name chosen here, temp. Move to the selection for I/O attributes. Note that CX Supervisor not only receives the I/O data from Omron PLC, but also it has the option for receiving data from Arduino OPC server or any other PLC or hardware driven OPC server. So OPC/other has been selected for I/O attributes as the data source for this point is Arduino OPC server. Click on the setup button to get the dialog box for communication control attributes. Here CX OPC comms has been selected for server field. Go for communication control properties dialog box. Under the server tab, you will find a list of servers successfully installed on this PC. Note that Arduino OPC server has been automatically added to this list, so this has been selected for server name. Go back to our communication control attributes dialog box and move to the item field. Arduino serial 0.A0 has been selected for item field. Arduino serial 0 comes from the communication settings for Arduino OPC Server, and A0 comes from declaration of OPC item in the OPC Case for Arduino. Let us finish talking about the point. Now I will show you the sequences of steps for creating this point, and after that we'll go back to our user interface. Now I want to talk about the graphical objects of this user interface. This user interface has 3 temperature displaying objects that have been created by dragging and dropping these objects from the graphical object toolbar. Temperature can be visualized as digital number, gauge style and 10 graph style. During the runtime operation of this project. Now to add the display effects for these objects, we have to assign or link the point to these objects by using a tool called Animation Editor. To add display action for this text object, go for Animation Editor by double clicking on this text object and get the display value analog dialog box. Here the desired point temp has been written for expression field, or this can also be selected by browsing the available points from the point editor. Now go back to our user interface. This way the same point has been assigned to the objects for gauge and 10 graph. Now we are ready to go for runtime environment for this project. Click on the run button in the menu bar to start the project. The project is getting ready to load. Finally, we have come to get our user interface running on this PC, as well as also Arduino OPC Server started to run automatically. If we go for Arduino OPC Server, we get the message clients on. That is, this OPC Server is now connected to the CX Supervisor SCADA interface. Go back to our user interface. The temperature reading here we are getting is the real-time temperature sensed by the temperature sensor connected to analog input pin of Arduino. Touch the sensor by hand to observe the change in temperature reading. The temperature reading is increasing. Now touch a heated soldering iron head to this sensor. Note that the temperature reading is getting increased rapidly. So that's all about the project I have shown you in this video. If you watch and enjoy this video, please like, share, comment and subscribe to this channel.